Thank you for joining this lesson. We're going to discuss Mathematics Paper 2, Three-Dimensional Geometry. In number 48, we are told that the figure below shows a right pyramid, VABCD, standing on a rectangular base of length 10 centimeters and width 8 centimeters. The diagonals of the base intersect at O, and M is the midpoint of BC. M is the midpoint of BC. Then we are told the vertical height OP of the pyramid is 12 centimeters and that all the slant edges are equal. So we can see the diagram here. We try to indicate some statements which are in the information but not shown on the diagram. We have the diagonals. The diagonals of the base. We are told that they are intersecting. They are intersecting at O. Therefore, we have the height BO, which is 12 centimeters. Yeah, the height there from the top to the base, 12 centimeters. Then again, we are told that they intersect at O. So this is O. M is the midpoint of BC. So with BC, we will have a midpoint M here. Yeah, this is going to be point M. That one should be known. So that is now the diagram. Calculate correct to 2 decimal places the length BM. The length BM. Remember, we all know that because there is a length of 10 centimeters, then from O to M, let me indicate it well. From O to M, we're going to have 5 centimeters then. So if that is 5 centimeters and the vertical is exactly 12, then we can get VM, Pythagoras theorem, whereby we will say VM needs to be 12 squared plus 5 squared, then we take the square root. So 12 squared plus 5 squared, then we take the square root. I'm getting a 13, but I'm required to give it 2 decimal places, so 0.00. These are centimeters. That is length VM. Next is state the projection of VB. State the projection of VB on the plane ABCD. VB is the line here, the edge VB is shown here. So its shadow, or rather its projection on the base, is going to be OB. That is what we call the projection, the shadow on a given plane for a given straight line. Calculate the angle VB makes with the plane ABCD. So if a line is making an angle with a plane, then that angle is strictly the angle between the line and its own projection on the said plane. Therefore, we need the angle between VB and its projection, which is OB, on the line, on the plane ABCD. Therefore, the angle is going to be between VB and its own projection on the said plane. Therefore, the angle is at this point. The angle between VB and its own projection. Now, allow me get that angle very fast by first of all calculating the length VB. Has it been provided? No. So the length VB is going to be, we can use triangle VBC, whereby we will say, because VM is already 13 and we have M being the midpoint here, so we can have 4 and 4 at this point. So that the length VB can be given by, when we take 4 squared and 13 squared, then the square root. So I'll take 4 squared plus 13 plus 13 squared, then I obtain square root. I'm going to get 13.60 centimeters. So now with the triangle VOB, VOB, remember we need this angle. I'm having 13.6 and I'm having a 12. Therefore, I can get this angle comfortably by using the sine of an angle. So the sine of the angle, which is unknown, the sine of angle theta is going to be opposite out of the hypotenuse. That means for me to get, so we can get a theta by obtaining the sine inverse of 12 out of 13.6. This is going to inverse shift sine shift sine 12 out of 13.6, 61.92. That is 2 decimal places. We have part C now. The angle between planes VAD and ABCD. VAD and ABCD. VAD is the plane on the left hand side with the base. For us to get angle between two planes, we need to get, first of all, we identified the line of intersection between the two planes, and that is line AD. So we draw a line perpendicular to AD through the first plane, a line perpendicular to the line of intersection. So a line dropping through that plane to the line of intersection. Then we do the same, a line again perpendicular to AD through the other plane. Now the two lines will give us the angle we desire. This is the angle that we desire to get. Assuming that this is point N, now we can use triangle VON to get the desired angle. The angle between the base and the VAD as a plane. Therefore, I'm going to use, now that I got, remember this is equal to 13, just like this one, just like VN, it's also 13. Again, we can talk of VO being 12 and ON being 5. Now that O is the mid of NM and NM is equal to AB, 10 centimeters. So we can use 5 and 12 to get the angle there. So I'm going to use tangent, whereby I will talk of tan of that angle being equal to opposite length. Let me identify it well. Yeah, with VON, we have a tan of this angle being opposite. That is a 12 out of 5. 12 out of 5. So 12 out of 5 to mean that theta is going to be the tan inverse of 12 over 5. This angle is going to be shift tan 12 out of 5. This is giving me 67.38 degrees. So that is the angle. We're also finding the volume of the pyramid. So volume of a pyramid is usually given by a third base area, which is a rectangular. So 10 by 8. A third base area times height, which is 12. This is going to be 4. going to be 4. Therefore, 32 by 10, 320 cubic centimeters.